Hello everyone. In this video we see how to create a pipeline and auto-scaling group with the help of Terraform. In the previous video we see how to deploy two services with a single load balancer with the help of Terraform. First we move to the IAM.tf. This is code build role. This policy for the code build. The IAM role for the code build. IAM role policy for the code build policy. And this is a pipeline that IAM role for the code pipeline role. Then IAM role policy for the code pipeline policy. Before moving to the code build part, first we see the build spec file. This is our build spec file. This is service 1, service 2. This is a Docker file. We run two services with a single Docker file. This is build spec file. In pre-build, there is will be login and second build command. First we build, then tag, and the post build we do docker push, and the artifact image definition 1.json, image definitions 2.json. Now move to the code build 1.tf. This code build part is attached with service 1. The name of this code build project is dr underscore docker underscore build. This is environment, log configuration s3 logs, and the source type we github, and the location we put es docker to git. This is a link of github. This now move to the second service of code build part and code build project dr underscore docker 1 underscore build 1. This is for service 2 code build, and environment, logs config s3 logs, source type github, location github UI, github link. Then move to an pipeline. This is first pipeline of service 1. The name is dr underscore pipeline. The source names source and provider github. Owner third party, the configuration that owner, then name of the repo, branch main, then the token of github, and this is a build. Then move to then deploy, then owner AWS, provider ECS, input artifact build output, the configuration, cluster name, cluster dev, service name act1 service. This is ECS service act1 service. Then file name image definition 1.json. This is pipeline 1 and second pipeline for the service 2, the dr underscore pipeline 1, the name of the pipeline of second service, then source stage, then move to then build process, then it's deploy, that configuration, cluster name cluster dev, service name act2 service, act2 service, file name is image definitions 2.json. This is second pipeline, and move to then auto scaling group. This is auto scaling group. Basically, auto scaling monitor your application and automatically adjust the capacity to maintain the steady, predictable performance at the low cost. Using AWS, using auto scaling group, it easy to set up application scaling for a multiple resource across multiple service in minutes. This is a auto scaling group for service one. The name of his auto scaling is ECS target maximum capacity 1, maximum capacity 4, minimum capacity 1, and the resource ID service cluster dev act 1 service. Then move to the policy. We add two policy, scale up policy and scale down policy. The name is scale up policy. Then service ID service cluster act 1 service, adjustment type change in capacity, and scaling adjustment 1. Now second policy is scale down policy, and we also attach the CloudWatch. The first CloudWatch alarm is name of the alarm is CPU high. This is attached with the scale up policy, and the matrix name is CPU utilization. And second CloudWatch alarm that is attached with the scale down policy, less than or equal to the threshold, and scale CPU high is greater than or equal to the threshold. The threshold is 80. Here the threshold is 10. And second auto scaling group that is attached to the service 2. The name has ECS underscore target 1, maximum capacity 4, minimum capacity 1. The resource ID service, cluster dev, act 2 service. This is auto scaling group. Sorry, auto scaling policy. Here we also add two policies, scale up policy and scale down policy, and two CloudWatch alarm CPU high underscore high 1. This attached with the scale up policy 1, and CPU underscore low 1 attached with the scale down policy 1. Now we create an S3 bucket also. Basically, the S3 bucket is used to storing the artifact for a pipeline. You can specify the name of an S3 bucket. A folder to contain the pipeline artifact is created for you based on the name of the pipeline. So now we run in Terraform command. The first command is Terraform init, and second command is Terraform plan, and third command is Terraform apply. After all these three commands is successfully executed, now move to in console, type code pipeline. Now here is two pipeline. The first dr underscore pipeline for the service 1, and second dr underscore pipeline for pipeline 1 for the service 2. On first pipeline, see this successfully executed our first pipeline. We can also check the logs also. This is our code build logs. After the pipeline was successfully executed, it create a artifact. Now move to an S3. This is our S3 bucket, ECS pip artifact that we created, and this is to dr underscore pipeline 1, dr underscore pipeline 1. This shows a folder to contain the pipeline artifact is created for you based on the name of the pipeline. This is two folder. Now we see our auto scaling group. First move on ECS, cluster dev. Here the click on act 1 service, first service. Now move to auto scaling group. See, our auto scaling group is also successful created and attached with an ECS cluster of a service 1. Minimum task 1, maximum task 4. Scale down policy, CPU utilization smaller than 10. Scale up policy, CPU utilization greater than 80. Take the action, remove first task when 10 is greater than CPU utilization. Take the action, add one task when the 80 is more than CPU utilization. This is autoscaling group of service 1. This is service 2. Click on autoscaling group. Here, this is autoscaling group for the service 2. Now in this video we see how to create a pipeline and autoscaling group with the help of Terraform.